Thanks so much for having me. It's a pleasure to be here. Indeed, I do support, advocate, endorse open science. So, in the spirit of open science, it's not just about the way that we do research, but it's also the way that we do our talks and research. So, everything is open. You can download these slides. You can scan this QR code or at any time go to this link, the 2024 Lingnan University, and it will keep appearing on the side. So, if at any point you want to take a look at some of these slides, very welcome. So indeed, we did a talk, and I posted this on a conversation, an interview, kind of. So me and Will. So I post everything on the Open Science Framework. So you're welcome to this, or if you prefer the YouTube version, it's over there. An interesting kind of complementary to what it is that I'm going to give you today. So I'm going to talk about the bridge between some of the things that I do and how I do my research and teaching with students at HKU, but also about much broader issues that have to do with what's happening in science and what's happening in the world and what should we trust and what should we believe about the things that we see. So not only this talk, not only what I did with Will, but just generally everything that I do is open. So you can go on YouTube and see all the stuff, plus all my teaching materials. So if you want to know how to teach open science and how to do all the stuff that we do, and I'll share a little bit of that. So really everything is on the Open Science Framework. So please go ahead and take that, use as you want, share, do whatever. This is what open science is about. So I'll start with something that we all really love, which is statistics questions, right? This is, we get up in the morning, the first thing that we want to do is think about statistics. But I feel it's a good initial demonstration for you to think a little bit about some of the issues that we're having. So it's a bit small, so I'll read this out to you. But it's something that we all need to consider when we read articles or when we look at the media and see a report of something in the news about a scientific paper. So let's say, and this is from a real project that we did, that we collected data for. So you read a media report about some experiment that had 20 participants, 20 people, and the report indicated that the results show support for the theory. So p-value lower than 0.05. My question to you, given that you have this study, suppose that I run exactly the same study. First study was with 20 participants. I run this again with 10 additional participants. What is the likelihood that we'll again find support for that theory? So again, p-value will be lower than 0.05. So you can start thinking, okay, how to approach this? What should I do here? Probably something to do with power. Maybe I need to do some Bayesian updating. So I have like a prior. I don't really know how to approach this. Generally, this is a tough question. First of all, p-values are very elusive. How to define p-values? What is support for theory? What do we know about these researchers? Where was this published? We have a lot of questions. But given that this is the entire information that we have, the question is, what is the likelihood? What do you think is the likelihood that this is going to be supported again with a sample of 10 participants? So we give this question to people, lay people, don't know anything about science. We try to explain this best we can. This is what came out. So basically what we see here is a distribution between 0 to 100. And what we can see here is people estimate this to be 58% likelihood. So it's not 50-50. So it's not like random, okay, whatever, 50-50 chance. It's a little bit above 50-50. And it seems like overall people are quite optimistic with this. So we ran this in 2022 on laypersons on MTurk using cloud research. Then another question for you. Okay, so maybe you had some trouble with the 20 people, so maybe you want to run this on larger samples. So how would you update your answer if I gave you exactly the same thing, saying the first study had 200 participants, or the first study had 2,000 participants? But then if we run this again on 10, on 100, or 1,000, what is the likelihood that this is going to replicate well? Another very complicated question, but we're scientists. We face this every day. We read articles, then we need to make a decision. Is this going to replicate? Should I build my research on this? We were having a discussion previously. Should I write a research proposal for GRF, building all this research because I want to find something interesting? So we manipulated this and we wanted to see, do people really update this? So on the left, you can see the control condition. So this is the 2010. But then if you multiply this by 10, so 200, and 100. So the likelihood increases from 58% to 69%. How about 1,000 and 2,000? It just increases to 70. So it seems like not, although these are different, control condition is different from these two, it's not by a lot. And there's no difference between the times 10 and times 100. Okay, so interesting. So lay people do this. Why even start with this? Why is this interesting? My conclusion from that and from what we did here in this project is that generally, seems like people generally tend to believe scientific findings. Even if there's a scientific finding with 20 participants, they tend to believe above 50% that things are going to replicate quite well. And then they don't seem to really understand what power is. And then even when we give them larger samples, they don't seem to take this into account and update their probabilities. Okay, so that's exhausting. A lot of statistics. What does this mean? Where does this go? How is this related to JDM or open science and all of that? We should ask ourselves, what happens with scholars? What happens with us? Do we know how to answer these? Because this is what we do in our everyday life. So this is a registered report. I'll talk about what a registered report is that I did with an undergraduate student. So he did this for his thesis. And as a registered report, we submitted a pre-registration plan to a journal. I'll talk about what that journal is. And we got an acceptance over the pre-registration plan. And then we proceeded to the data collection. So this is a guaranteed publication done as an undergraduate student for the thesis. And we found support for something. So all the findings that I showed you actually show strong support for what? The strong support for Kahneman and Tversky in 1971. So people actually don't know this. But Kahneman, who passed away this year, unfortunately, the only psychologist to ever win the Nobel Prize for economics, started his journey, his first project ever, the thing that behavioral economics started from, judgment decision-making started from, is starting in 1971, when him and Amos Tversky went to statistician conferences, to APA conference, and asked people like us, what do you think the probability is that this is going to replicate? So this is a classic. It's been cited many, many times. This is what it is that they showed. Very similar to what I showed you here, only a little bit with more statistics. So p-value lower than 0.05. We translated this to laypersons, but they ran this with scholars given that, which is very, very similar to the questions that we had. So basically, you had a sample of 20 subjects, p-value lower than 0.05. How likely is it that it's going to replicate with 10 subjects? So honestly, I've done judgment decision-making for many years. I did not realize that this is how Kahneman and Tversky started. So this is really, really interesting. And how is this related to anything about open science and all that? So this is the seminal paper. It's been cited 5,301 times. It's related to all their prospect theory and all the stuff that they're well known for and all their Nobel Prize winning stuff. And they showed that even when they go to Mathematical Psychology Group and American Psychological Association, statisticians and scholars get this very, very wrong. They estimate the probability to be over 80%, which is outstanding. And this is a problem. And this is the first time that they realize people are biased, not just people in the street, not just laypersons. We, researchers, we're biased. We have a big problem, even if it's our job. And we're statisticians and we study statistics all of our lives. We'd get these questions very, very wrong. So I was happy to be able to revisit this with an undergraduate student and find support for this for almost all the predictions that we had. So already an interesting takeaway. So surely now that we've alerted the world in 1971, and we told people that they have this problem, that they don't know how to take power into account, and that they're over-optimistic about the replication of results, well, surely now we don't have this problem anymore. That was in the 1970s. This cannot happen today. How can this happen today? So here's a book that came out in 2018. And I discuss with a lot of people in my department. Every year, I see at least one undergraduate student or MSc student or MPhil student or PhD student do something about social priming. And again, we try in all my courses to say social priming is a big problem. I'll discuss some of the social priming problem. But John Bargh, with a big book, New York Times bestseller, Malcolm Gladwell says, this is a brilliant and convincing book. Comes out in 2018 and says, social priming is this amazing demonstration of psychology. It just shows everything about how brilliant everything is, and we're affected by the context and so forth. In the spirit of Daniel Kahneman's Thinking Fast and Slow, which is interesting. I also Googled the Google talk to see how John Bargh presents this. You cannot read this, but I also screenshot the subtitles, and it's related to the upcoming elections in the US. So I'll just read this out to you. No one has ever turned a conservative into a liberal. So we've got these two camps, the Republicans and the Democrats. He wanted to convert conservatives to become liberal. Having them feel physically safe, we had them imagine that they were given a superpower by a genie, but the people were made to feel invulnerable to harm. The conservatives moved much closer to the liberal attitude as a result of feeling physically safe. So if you just use social priming, you can get a conservative to turn into a liberal just by telling them that they have superpowers by a genie. This is an amazing find, right? So this is published here in 2018. So many years after 1971. How many samples are a little bit bigger than 20? We've got like 141, but we've got 4 different conditions. So we can see that it's about 30, 40 per condition. P-values below 0.05 for sure. So 0.044 or 0.034. So this seems to be very convincing evidence. And you can see here, this interaction from here to here, it seems like the Democrats and conservatives seem to be a lot closer to each other. So this is fantastic, right? So Daniel Kahneman, the person who did in 1971, who said, beware the law of small numbers, beware of small samples. He, in his Thinking Fast and Slow, 2011, has a whole chapter about social priming. How does he cover social priming? He says the marvels of priming. How does he describe it? The results are not made up, nor are they statistical flukes. You have no choice but to accept that the major conclusions of these studies are true. Not only are they true, they're true for you. So Daniel Kahneman, Thinking Fast and Slow, in his big book, fourth or fifth chapter on social priming, says that this is the future of psychology. What happens next? After the book came out, in 2011, we had a few things. I was discussing this with Will, feeling the future, false positive psychology. We started to understand that something is going on, and Kahneman became very concerned over this. So in 2012, 1 year after the book came out, he wrote an email to all the social priming people saying, please check yourselves. I have just recently published a book saying that social priming is this amazing thing. You really need to be careful about this. So he says, all I personally have at stake is that I recently wrote a book that emphasizes priming research as a new approach. Count me in as a general believer. But I see a train wreck looming. If you don't get your stuff together, make sure that this is solid. I'm going to come out looking bad over this. Now, how would we know whether this is solid or not? There are many ways to approach this, but one of the obvious ways that we realized in 2011 is that we need to start running replications. What happens when we run replications of social priming? Very bad things happen. Preferably, you should do this well-powered, independent samples with many labs around the world and as a registry report, and I'll talk about what a registry report is. But we've had a lot of failures with social priming again and again. Every time that we try with these classics, with 3,000 citations, hundreds of articles on social priming, again and again. So through and wire, so hostility priming does not replicate, not just once, twice. Mass replications, millions of dollars. A lot of people, ours committed to this commitment priming, honesty priming, intelligence priming, therefore, we just can't seem to replicate these things, all these big classics. And every year I see another student, I see another scholar trying to do another research on priming. And as much as I want them to do well, they just don't listen when I tell them, you should find something that is more solid. So beware, look at replications, make sure that what you're doing is really solid. And at the end over there, I think many of us are familiar with this John Barge elderly priming. So he did this thing where he primed elderly words and then people walked slower to the elevator. Another sample with 20, 30. And then finally Kahneman, poor Kahneman, but he's already in his 80s. But Kahneman in his 80s goes on to a blog that blog had a cover of the social priming literature in his book and said, looking at all of these things that Kahneman did in his chapter, none of these things seem to replicate. All of these are very bad studies. So that chapter in Thinking Fast and Slow is a problem. And then came the amazing admission by Kahneman. So Kahneman, about 80, goes to this anonymous blog and writes this comment. And this is what he writes. What this blog gets absolutely right is that I place too much faith in underpowered studies. There's a special irony in this mistake because the first paper that Amos Tversky and I published was about the belief in the law of small numbers, which allows researchers to trust the results of underpowered studies with unreasonably small samples. Our article was written in 1969, published in 1971. I, Kahneman, failed to internalize the message that I alerted the world about. How ironic is this? So he admitted that chapter in Thinking Fast and Slow is very flawed. I fell into the trap that I warned everybody around the world about. So even when we know about a problem, it doesn't mean that we can avoid it. If Kahneman fell into this trap, oh my gosh, we should be very, very careful with this, right? So when I saw all this happen, so this is 2017, I was a postdoc at Maastricht University in the Netherlands. This was heartbreaking for me. And this is not the only thing. I was also involved in lab that did ego depletion, and that kind of fell. A lot of things just came crumbling down in 2017, 2015 to 2017. And then he gave this interview. So the nice thing about Kahneman is that he's very humble. He's able to admit mistakes, which is more than a lot of us can do. It's very difficult for us to admit that we were wrong about something. And honestly, when I was doing my PhD, and up until 2016, 17, I was following the biggest trends in science to do all these things. So this is what he wrote. Well, I was wrong, at least in this case. The studies of behavioral priming that I had studied in that chapter were largely discredited in the famous replication crisis of psychology. Great. But then he wrote, over there on the right, there were essentially no takers for my suggestion from 2012 that priming research should proactively replicate each other's work. So I read this, and I thought to myself, it's great that Kahneman reached out to the social priming folks in 2012 in order to make them contemplate their own research. But then I thought to myself, so Daniel Kahneman, admire your work. This is great work. But who is going to replicate your work? Why did you not accept responsibility of maybe I should check my own work? How do you know that in 1971, what it is that you published? How do you know that this is replicable? Who is going to do that? So it's much easier for us to see flaws in other people and see weaknesses in other people and call them for action. But do we look inwards? Do we look at what it is that we're doing in order to check ourselves? So who is going to do the JDM? checking who is going to do the replications for that. So this is a big question that I had in 2017. Who is going to try and make sure that behavioral economics and judgment decision making is solid? So we are. So I decided I am going to do this. If nobody else is going to pick this up, at least somebody will try and do this in order to help judgment decision making and behavioral economics. So I formed a team. And this is the team that I formed. We've got 45 early career researchers from around the world. You can't really see this, but we've got all sorts of people from China all the way to Brazil, many places from around the world. Many of them, unfortunately, are from weird cultures, from Western cultures, but we're able to get people from around the world, including from this region. In addition, I involved all of my thesis students. So if you do a thesis with me, you had to do things as a replication. We do more than a replication. We do a replication and an extension. So we extend the literature. And even more than this, 390 taught course students at HKU. So one of the amazing things that HKU let me do is revamp all of my courses to run hands-on replications with students doing a one-semester course. Undergraduates, as early as second year, some of them barely ran a t-test, maybe on SPSS or something. So I wanted within one semester, or with thesis students within one academic year, to bring them from not knowing anything about statistics methods to being able to write an entire report that would be publishable and sent to journals, replicating some of the classics in the literature. So you can see this was a massive undertaking. It took me a few years to get into it. But finally, this team is called the CORE team, Collaborative Open Science and Meta Research team. And we have a Google Scholar, so you can check us out. And you can see that we have increasing impact. So overall, when I look at these 6 years, we've had like 45 different publications. We have a lot of register reports. And we not only do these replications and publications, but we also do a lot of guides and resources so that if you want to do similar things in your courses, you have templates, you have guides, you have examples. You can do everything, take as is, and implement this in your own courses. This is just like a summary of what it is that we've done. But we've done over 150 replications and extensions of judgment and decision-making and behavioral economics. So we decided we're going to check the credibility of Kahneman's work and everybody else who followed on this. So we've done a lot in these 6 years. How about publications? At the beginning, I did not think this is publishable. People said, undergraduates in Hong Kong, you're a first-year assistant professor, second, who's going to publish these things? But finally, 2021 was the first time we ever got to publications. And you can see the impact has been very, very strong. So in the first year, 15 publications. And how does this work? You can see all these underlines. It's very, very small, but all these underlines are Cantonese Mandarin names, so Chinese names. You can see at the end, there's also the teaching assistants. So they get credit for this because they were involved. Everybody gets contributorship support. The first ones, the ones that are here on the left, are early career researchers. So first, the students do this as a thesis or in my courses, but then I'm not sufficiently confident that this is really good work. So I go on Twitter, now it's also Blue Sky, and I invite others and say, we did this thing at HKU. Who wants to join us? And then early career researchers, all the 45 from around the world that I told you about, come in. They join as first authors, and then everybody is shared first author in a note. And then they validate everything. They make sure everything is solid. And together we submit this to journals, and they address all the peer review. And this is just a model that works. And 2021 was the first time that these things started to come out. So what to take from all of this? So is this really, so we started from a statistics question. It seemed to be about power and sample size and all this. Is it about misunderstanding statistics? Is this the issue? Is this what's happening with social priming? So unfortunately, it seems to be a lot worse than this. So one of the things that we realized when we see Kahneman, even Kahneman falling into this trap, that we see ourselves falling into the trap, the statisticians in 1971 falling into this trap, is that we understand that first we alert the world in judgment decision making. We alert people that they're biased and they're fallible. And then there's all these things that they should worry about when they do financial decision making or health. But then we are also fallible, that we also have these problems. We're biased, and even worse than this, we follow incentives. So when we're incentivized to go a certain way, then we keep going that way, just like social priming did. In addition, it's not all about the people. Because people follow incentives, there's also something about the system. So we have this misaligned prestige system that we have to talk about. We're obsessed with this, especially here in Hong Kong. We really care about the number of publications. We care about these impact factors, and we care about QS rankings. We care about what is the impact of this? How do we know what the impact of this is? And can we do better? And underlying all of this is that actually it's a trust system. So we trust social priming. We trust Kahneman in Thinking Fast and Slow, chapter 4 or 5, that when he writes about social priming, he knows what he's doing. We trust John Barge, that when he comes out with a New York Times bestseller, we trust them. How do we trust them? Why do we trust them? Did they earn this trust? How do we know that this really works? It doesn't work. So we have a lot of issues. I'm going to give you a few examples of systemic issues in hiring, promotion, funding, have been subjected to some of these things. So I feel like it's very important that I share this with you. But I do want to give you some of the examples that I've been giving for many years for you to understand some of these challenges. And this happens every time I sit and I talk to my colleagues about how we hire, how we promote, how we fund people. So I'm going to give you a very simple example. And this is something that you'll be facing in Lingnan University. You need to hire somebody for the next assistant professor role, or another postdoc, or another student. So let's take, for example, we have two candidates for a professorship, right? They have exactly the same resources. So they have 2,000 participants per year. They have a 50% a priority true hypothesis. Let's say they have a typical effect size, and none of them does p-hacking. We'll talk about p-hacking in a sec. Let's assume that all this is solid and they have exactly the same resources. One of them, candidate A, publishes 33 statistically significant papers. Candidate B publishes 21 statistically significant papers. Which one would you hire? So no more information. This is all the information that you'll get. How many of you would hire candidate A? Raise your hand, please. Many of you, most of you? Okay. How many of you would hire candidate B? Raise your hand. None of you? Okay. So at this point in time, you must be thinking, okay, there's got to be a catch here. He's trying to show us something, and you'll be right, because I am trying to show you something. Something is hiding behind this. What is hiding behind this? We just talked about the issues of power, credibility, and all of this. But before I discuss this, I'll give you another example. This is another one, HKU. We really proud ourselves in our impact factor, science, nature, PNAS, and all of that. Candidate A published 10 high impact factor publications, but no preprints, no privilege ratio, no materials, data code. Candidate B publishes 10 diamond open access. It means no fees for anybody to read, low impact factor publications, but they're all pre-printed, all registered reports, all material, data code share. I'm not going to ask you. I'm just going to tell you at HKU, there's absolutely no doubt that we go for candidate A. Candidate A by far, right? So if you don't stand with these high impact factors, nobody cares about if you share their data. If you did preprints, register reports, who cares about that? Right? So what's the impact of all of that? So actually, I ran this on a Twitter thread. So I ask a lot of things on Twitter. You can see our results. I'll just say here, high impact factor journals versus registered reports. You can see that very dominant bias. And I have to say that many of the people who follow me on Twitter are open science folks. So even the open science folks say, no, we want high impact factors, not registered reports. This is the person that we'll hire. But I also did this with a bunch of other things, PhD from Ivy League. I have a whole different lecture about all the other biases, but I'll focus on this bias here. So let's just translate the numbers that we had from this statistically significant papers. This is the thing that we're missing. If they have exactly the same resources, they need to apply these resources differently when they conduct their research. So that means in order to get these 33 statistically significant papers, you just cannot spend a lot per condition. So if they did exactly the same things, comparable research design, typical effect sizes, they did exactly the same things, but just the mere number hides behind it. The 33 statistical significant paper, the N per condition, which is the power, is 21, compared to candidate B, who said, no, I need to validate and make sure that this is better, so I'm going to increase the number of people per condition in my papers. How does this translate to the things that we care about in terms of credibility? Candidate A, with this N of 25 per condition, which is a little bit like social priming, where the thing 15% are false positive, 25% is replicable. How about candidate B? Reduces to 6% of false positive, and 76% is replicable. So do we ever look at our candidates, how many they invested per condition, whether this is likely to be replicated or not? We rarely do. We count publications, but we don't understand what the back implications of this are. So you need to translate to that. And I think that once we present this kind of dilemma to departments, then they realize, no, science needs more of the candidate B, because who's going to, at some point, everything is going to crumble down under candidate A. So if you want to know a little bit more about this, there's a famous paper that came out that talks about this kind of nudging, just changing the way that things are presented, which leads me to explanation of misaligned incentives. Also very small, so I'm going to read this to you. But you can see me on the right side trying to do credible research. So striving for knowledge. So we really care about systematic replications, and we care about all kinds of things like papers that are solid, not just about how novel and groundbreaking and counterintuitive things are, but also about, are things solid? When we communicate things to students, to practitioners, to policymakers, do these things really hold? So we care about this on one side, but the incentives over here on the left side are chasing matrix. So matrix misalign almost everything because they care about interest, novelty, mostly innovations, mostly leaders, promoters, quantity. All these things tend to, it's really like a big competition between the incentives and people like me who are trained researchers just need to do things. So there's this famous paper, if you come from business schools, likely you know this better than psychology, but Stephen Carey in 1975 had this amazing paper on the folly of rewarding A while hoping for B. He was talking about we reward research, but actually what universities do are teaching. So we don't reward people for teaching, we reward them for research. So we're hoping that they're good teachers, but so there's the folly of expecting people to be good teachers when we reward them for research. But actually my take on this is that we emphasize prestige and novelty while we hope for accuracy and credibility. Are we going to get to what it is that we hope for? If we have misaligned incentives, then we really don't. And then there's this main challenge. The main challenge is when you give people incentives, they follow these incentives. Now, there's a little bit of a problem with the speaker. I show this to my students. But basically what this one does, it's like a comedy take on what actually people do when giving these kind of incentives. So they play around. Now we have a name for this. We call this p-hacking or questionable research practices. So I'm not going to play this. I'm just going to move. But how do we know whether people are playing around? So in 2011, when we realized we have all these challenges and we have a problem with social priming and Kahneman is calling everybody to check themselves, we want to see, do we have a problem or not? So we start asking people, are you doing these kinds of things that we call questionable research practices? And the first one that came out in 2012 was basically, so you'll see here, all these things on the bottom, all these things here are questionable research practices. So for example, failing to report all dependent measures. We ask people to self-report. When we ask people to self-report, do you not disclose all the dependent variables? People say 78%. 78% self-admit. This is before, And then we ask people, looking around you, how many people are doing this around you? So when we do this and we make some adjustments, it goes up to 100%. And we've got things like optional stopping, and we failing to report all the conditions and rounding down p-values and like a bunch of things. At the end, it says falsifying data. So we ask people, just, admission, do you falsify data? Self-reports 9%. When we ask people, do you see other people around you falsifying data? It goes even more. Now, before we do anything with this, we need to replicate this as well. Does this replicate? Maybe it's just this very weird sample came out from we don't know where, right? Problem is, by now, we've had a lot of these things. So all of these are papers just asking people, are you doing these things? So we summarized all of that. And oh my gosh, people are doing this. And they're self-reporting to doing this. This is even before we actually look at what it is that they're doing. These are self-reports. So you can see all of those, harking, how many people are doing harking, everything between, 20% to 60%. Just unbelievable. And it keeps on going. Just unbelievable. Switching analysis selectively, doing all kinds of things. So now we know incentives really work. If you incentivize people to publish, this is what they're going to do. Yeah, of course. So well done us. We've done well as universities. People are, and I have to say, every year I'm a second examiner on students' reports. Every year I have a lot of questions because some of the things that come up make absolutely no sense. But we don't force our students to share their data in the code. Whenever I ask for this, their advisors get really mad with me. Like, why are you asking for that? Like, first I want to see maybe there's a mistake. Maybe I can help you fix this mistake. But second, I already know some of this is like too good to be true, and people are playing with this. So we do this. We teach our students to do this. We tell them they need to graduate. So p-value better make your professor happy. So they do this. We don't have a lot of time, but I demonstrate to my students how to do p-hacking. I think it's really, really important that we understand what are the implications of optional stopping, what are the implications of control variables, what are the implications of dropping conditions or dropping participants. So if you want to know how to do this, a lot of tools, also a lot of videos of me showing to my students how to do this online. But we need to understand the implications of this. So one of the things we were talking, me and Will, about this is like p-hacking, optional stopping. There's this thing about people don't realize, even if you've done research for a long time, you don't realize that when you peak and collect more data, there's this thing called the dance of the p-values. They go up, they go down, and at some point, and these simulators will show this to you, at some point it will come down below 0.05. So you are able to find statistically significant support for findings that are absolutely not there. So people are doing this, questionable research practices, and there's a way to do this. In addition, I also demonstrate how this has happened in our literature. So one of the things that I recommend to you or to your students or anybody who decides to do research on something is to look at an entire literature. So maybe this is the more important one, but I don't know how much you'll be able to see of this, but I'll try and show this because I feel like this is the more important one. We have tools now. So we can check credibility of all sorts of things. And we have Shiny apps that are based on R. So you can even take the code and work with this as much as you want. one of the suggestions that I have for you before you write your GRF on some literature or before you decide what to give to your student is just have them code all of the statistics from these papers. So for example, here you can see T of 47 degrees of freedom equals 2.5. So you enter all the statistics on the left, and then a bunch of things happen to you here on the right. So luckily for this nice shiny app, some people already included some data sets. So I'm going to use the elderly priming. So this is the social priming that we talked about. This is John Barge, from the same person who did the book in 2018. So when I press this, you see that all the statistics, Daniel Lakens, who is a big name in Eindhoven in the Netherlands, who does open science, coded all of this. So you see, he just took all the statistics and he put the p-values in there, and he just took all of the social priming about elderly and put this in here. Now, some of us don't know how to do a meta-analysis. Some of us don't know how to look at p-values. Some of us don't know how to do all these things. But the nice thing is that now you have tools to show you how to do this. One of the first tools, maybe you're not familiar with this, is StatCheck. StatCheck basically is a grammar spelling tool for statistics. So it allows you to check whether the statistics are solid or not. So it takes the T or the F and then compares this to the p-value and says whether there's a problem or not. And when there's a problem, it just flags it for you in order for you to be able to check whether the p-values are solid or not solid. So I strongly recommend for you to take your own articles and put them in there. I think you'll be surprised. I was surprised the first time that I uploaded my articles. And now there's a shiny app, can automatically, it extracts all of the statistics from your own article, and then it automatically puts this into that and checks it for you. So very important, especially before you submit somewhere, to do this. Now all kinds of journals like Psychological Science, there's a new editor called Lingnan University. She's very open science oriented. So they implement these kinds of checks, but you want to make sure that this is implemented. The second thing is that you can have a meta-analysis, and meta-analysis are not easy to do, but let's say this allows you some kind of a meta-analysis, and immediately you can see it's wonderful. They did all the funnel plot for you. So I don't know if you know how to read the meta-analysis funnel plot, but basically what this does is that you've got two triangles. One of them is under the effect that was found, in this case 0.5, and another triangle is under the null, and this is the white one here. What you can basically see here is that generally if this was credible findings, then you would have a lot of dots all over under the 0.5, all over this triangle that's showing an effect. However, what you see here is very different. You see that all the dots are here just outside the triangle that is 0. That is a very strong indication for publication bias, because when there was some findings that were not lower than 0.05, they were just not published. So this is one of the many indicators that we have, whether there's publication bias or not. And all you have to do is just put the statistics on the left and automatically created this for you. In addition, it gives you all the meta-analysis, and it does the Eggers test and the bias-corrected test and all of that, but it just gives you an example. Another thing is that a tool that we have is called p-curve. So it looks at how likely the p-values are to be real. So the green one, I don't know how much you can see this, but the green one is what we would expect from reality. So most of the p-values should be lower than 0.001. Then a little bit less is 0.01, a little bit less than that, 0.02. So generally the trend is supposed to be like this. What you can see with the social priming is that most of the findings, 44%, are just below 0.05. It means that somebody was really pushing this in order to become less than 0.05. This is indication for questionable research practices, right? And in addition, we got some statistical inferences from the p-curve. So do these studies contain evidential value? Are these considered to be solid? So it's not. We don't find any support. If there is some evidential value, is it inadequate? Definitely inadequate. Studies lack evidential value and were intensively p-hacked. So we find support for this. So now all you need to do is take all of the literature that you want to build yourself on, put it on the left, run this quick analysis, and then see, is there something solid in this literature or not? Now we know social priming, elderly priming, definitely a big problem with their publication bias, intensively p-hacked, and so forth. So we really need to be very careful with all of that. So maybe people do this. John Barge maybe did this. Social priming maybe did this. But people don't do this anymore, right? We have identified this in 2011, 2015. We started doing all this. I only became familiar with 2017, but 7 years later, surely nobody is doing this anymore. This is from this month. This is Juliana Schuler. I don't know if you're familiar with the Francesca Gino scandal. Big story. It's affecting all of us, especially if you're on the border between social psychology and business school like me. This is a big shock to us all. There's all kinds of things. She sued the people who found the mistakes in the research. It's not just about her, but also some questions about Dan Ariely. There's this big paper. I can talk about this for a whole semester, seriously. But I just want to say, all of her co-authors formed a team called many co-authors to check all of the research that was done by Francesca Gino, and we're talking about hundreds of articles. They wanted to see whether the studies that were done by Francesca Gino were fraudulent. Right? The issue is, you look at these papers again, and then you realize Francesca Gino is not the only person who allegedly did stuff over there. But Juliana writes this. It's too small, so I'm going to read this out to you. Okay. My final audit from the multi-co-author project is now posted, following with a retraction notice. So this was retracted based on this report that she had. I wanted to correct the record for two immediate false narrative emerging. First, I see no evidence that Gino was involved in any of the studies. So it's incorrect to blame Gino for the primary issues in this paper. So the retraction is not about Gino. He just looked at the paper because Gino was involved in a co-author. What happened? Second, there are issues in every study. I was the student investigator in charge of running studies 3 and 4, 10 plus years ago. The key results were barely statistically significant due to research practices I now identified as p-hacking. This is a big person in our field. This is not Francesca Gino. This is not fraud. This is a person admitting that 10 plus years ago when they published with Francesca Gino, they did p-hacking and questionable research practices. To end, I am ashamed of helping publish this paper and how long it took to identify its issues. I'm not the same scientist I was 10 years ago. I hold myself accountable for correcting any inaccurate prior research findings. If this thing with Francesca Gino did not come to light and they did not take this many co-authors, who would have found this issue? How would we have known about this p-hacking? Do we replicate? Do we assess? We really don't do any of this. So it's not just a make-believe kind of thing. So this brings me to 10 high impact factor publications versus 10 diamond open access, all pre-printed, all registered reports, all materials data code shared. So given Francesca Gino, given Juliana, given all that we know about what people are doing based on incentives, think to yourself, who is more easily checked? Who is more credible? Who does more solid research? Who do you want to be around you? Who do you want to give students to? So what does the high impact factor say? It doesn't say anything. Now we've got the many co-authors just trying to revisit everything and seeing just how big of a problem this is. I like this thing at the end. I'm just going to say, many people follow the impact factor. I follow the top factor. So it's called transparency and openness promotion, top factor. They look at data transparency, study pre-registrations, replications, and all that. I just want to say that there is an alternative to impact factors should you want it. In addition, we need to really look at this pyramid. And in this pyramid, down here on the bottom, it says status quo research. Not pre-registered, no data and materials are shared. Chris Chambers, who is the inventor of registered reports, says should not inform policy, and we should not inform the media about this. As you move up, you can say, okay, exploratory open science. It's exploratory, not conformative, but at least we have open science. We can validate this to see if there's fraud or questionable research practices. That's already a little bit better. Confirmatory open science, pre-registered, already a little bit better, but we only get to green when we get to registered reports. So I'll talk a little bit about that. And the greenest is a meta-analysis of registered reports, which we don't have on any topic right now. Another challenge. So we're moving into a different arena. And this is the biggest problem for me when I came into a PhD. I could not believe that this is the way that we do science. How do we peer review one another? We don't have any access to the data in the code. How can I go over as a second examiner over a student's project when I don't have any access? I can't see what happened over there. So will you please peer review this for X journal? I say, yes, I would love to. Can I please see the data in the code? I say, no, we can't. And even when we have all kinds of available upon request, I requested many times. And we'll say, okay, so we don't need it as a peer reviewer. We'll get somebody else who doesn't want the data in the code. I'm just like, it's unbelievable. Can you review my research project? Sure. Can you show me all the work you've done? No. In addition, taxpayers, it's just amazing that they don't have access to the thing that they pay for. They pay my salary, they pay your salary, they pay our research. They don't have any access to this. We put this behind a paywall, and then we don't show them the process, right? You pay my salary, but you don't get access to my work. How ridiculous is this? What kind of a science is this? I really couldn't believe this. And then we need to talk about the elephant in the room, which we never really talk about, is for-profit publishers. It's unbelievable. It's just such a scandal. I don't know how we live with this. But nowadays they've invented this. They triple dip into our pockets, into the taxpayers' pockets. On one side, we've got the subscriptions. We universities pay tons of money to access the research that we published, that we did. No added value whatsoever with these publishers. And now we've got this open access model where ridiculous sums of money, tens of thousands of US dollars in order to get one paper published over there. So libraries pay subscriptions, laboratories like ours pay APCs. We don't really know how much each person pays. Somebody pays this. And then there's just so much waste in this. Some more funny videos that I typically show my students. I'm going to skip those because we're short on time. But this is a big problem, and we really need to address this head on. So this is my summary to this. I it was just open access week at the libraries. So last year at HKU Library, I gave a talk about this insanity. And it's the first time that I got to sit down with librarians. And finally, I found my only ally at HKU talking about open science are the librarians. Thank God for the librarians. Why? Because it costs them so much money to pay for what it is that we do that is inexcusable. Deliberately, I write this, bordering on the immoral. The stuff that we do with paying for these for-profits, there's no way to explain this. So they're just, we created this monster. We really need to get away from this. What should we do? Now, I got a hint of how much money we're making. So I'm going to give you my unsubstantiated estimate. So based on what I've seen from HKU reports last year with Open Science Week, I know that 90% of HKU library resources go for subscriptions, and then in HKU it's 200 million. So I'm thinking, okay, there's 8 to 10, depending on how you look at this, universities in Hong Kong. And then in addition to subscriptions, we've got all the scholars that are just paying these APCs. My estimate is that annually, we're paying 2 billion Hong Kong dollars to these monsters, to these for-profit publishers. 2 billion Hong Kong dollars. The things that we can do with 2 billion Hong Kong dollars, just there's no excuse for this. We really need to revisit this. Anytime we talk to any decision maker, any policy maker, we need to tell them. Actually, you think it's impossible to get away with this? The Dutch just decided they're not paying anymore. MIT decided they're just not paying anymore. They decided, okay, block our access. We won't say how, but there's now other ways of us getting access to our research. Right? If our students know how to do this, we know how to do this. Finally, going back to the replications. So if we realize we need to understand the credibility of our research, so maybe we should be doing replications. Probably there's a lot of replications out there. How many replications are out there? So we look across fields, psychology, education, economics, linguistics, ecology, language, special education. What are the rates? How many of all the papers are replications? In psychology, it's 0.2. 0.2. How ridiculous is this? We just don't revisit any of the findings. We don't know if they hold or don't hold. Nobody is doing replications. I'm doing this with my students. We try and we do a fairly good job at getting into some of the journals, but we're the only ones doing replications and submitting these things. So absolutely ridiculous. What happens when we do replications? It doesn't look good. So I'll just give you in social psychology. 2015 came out a science paper. Me and Will were discussing some of the impact that this had, changed everything that I did in my career. Tried to replicate 100 different findings, about a third replicated. Then we said, okay, so maybe the stuff from social science that is published in Science and Nature, maybe that replicates a lot better because it's science, it's nature, it's high impact factors. Right? Only 13 out of 21. So Brian Nosek from the Center of Open Science is the one who summarized this entire literature and said across all the 6 large scale, 90 out of 190, 47%. And these are the top journals. These are our best findings. This is all the psychological science and the JPSPs and the nature and the science and the PNAS and so forth. We're at 47%. I've been tracking this for a very long time. This is my unofficial summary. It's somewhere between 30% to 50%. And in the things that do replicate, the effect size, the impact of the intervention is about half of what was published. So it's not even a coin toss. So when I came to HKU and somebody said, here's the social psychology book. Please teach this. Just like I was flipping through this. I'm like, okay, this doesn't replicate, this doesn't replicate, this I don't know, coin toss. What should I do? Just put this aside and I'm not teaching this book anymore. This is the reason why I'm doing replications with my students, because we need to revisit everything together. We just cannot take for granted what is in these books if these are the best findings that we have, 30 to 50%. A lot of people push back and say, no, this is a psychology problem. It's not even psychology, it's social psychology. It's not a real science. If it's a science, it's science of blah, blah. It doesn't hold. If we go to other fields, it will be much better. The problem is, maybe you could have thought that in 2015, when by now we know this is a very big science problem. If anything, the social psychology is doing better than many of the other exact sciences. So this paper came out like a couple of years ago, Science in terms of preclinical cancer biology. So many issues. I can talk about this for 2 hours straight. They started with 193 experiments, but they only could really conduct 50 because they couldn't understand what's happening in the articles. They were trying to follow the instructions, but we don't share anything in the articles. We don't tell people how to do so. Already, just reproducibility-wise, from 193, they went down to 50. And then what happens at the end? So you can see succeeded on all 3 criteria, 2 out of the 23 papers, 2 out of the 50 experiments. So we're at 11%, 6%, 18%. Cancer biology. If social priming doesn't replicate, okay, you tried some stuff, didn't work out, okay, so you're not as confident or you didn't become a liberal, fine. Cancer biology, people suffer, people die. This is a real issue. This is cancer biology, some of our best journals. We should aim for better. So my summary of this whole thing is that we're in need for talking about this. We need to reassess. We need to self-reflect. If our top people, like Kahneman, like Juliana, if our top people are revisiting what they're doing, if they're questioning some of the things in the literature, definitely we should as well. So we're way overdue for self-reflection, reassessment, and improvement. I have this cartoon. Some people push back on saying, no, we don't have any problems in science. Look at the electricity. The planes are flying. Science is working, right? So this is for those people. I say, okay, we should talk about these things a little bit more. But at the very least, it's a little bit like climate for me. Like people are talking about livable cities, green jobs, renewable, clean air, clean water, healthy children. And then somebody comes up and says, what if it's all big hoax and we create a better world for nothing? So in open science, we talk about, increased transparency, preventing p-hacking, doing replications, open access to scientific. And then somebody says, but what if this is all big hoax and we create a better science? I think let's just do better science. Let's just improve the way that we do things. We can learn from what it is that we've done so far. We have meta science now. So up until the 2022, I was a little bit alone with this, me and my open science folks. But luckily, we got a big boost from UNESCO. So finally, UNESCO acknowledged this, came down together, world leaders, and say, yeah, we must do open science. So it's no longer a question of whether we should do this. It's like, how should we do this? And we're here to help. We've been at this for a while. I've been doing this for 7 years, and I want to empower as much as I can in others to do more open science and to revisit and to increase our credibility. It's not just UNESCO, but also NASA with the Biden-Harris administration decided that 2023 is the year of open science. So we haven't heard anything about this in Hong Kong. Maybe we should have talked a lot more about this. But there was a lot going on in Europe and in the US. And I think the solution is, because this is not an individual level thing, there are more systemic issues. We need to do a change. And the Center of Open Science offers a model for change. So they talk about make it possible. At the beginning, it wasn't possible. We didn't even have a way to do a pre-registration or to share data and code. Then make it easy. Center of Open Science. I have to say, Open Science Framework is not an easy interface. It's not great to work with, but they're working on it. And we have more and more tools that are making this easy. Then, at some point, making it normative. And we've really failed on this, especially here in Hong Kong. Maybe the Dutch are doing better, the Scandinavians, a bit in the UK. Make it rewarding. Halfway there, and I'm going to talk about this halfway, not so much in Hong Kong, and we are focused on social psychology, but I'll tell you. But I aim to make it required at some point. I think there's no alternative to it. Finally, we need to make some adjustments to the way that we do research to avoid things like fraud, like questionable research practices. So all this hour took a very long time, but finally, hopefully, we're aligned on the need for a change. So now I'm going to spend about 20 minutes to talk about some of the solutions and how I did this at HKU with my students. So my main message is share everything as much as possible, teaching and research, and in research all the way from the beginning to the end. Conduct registry reports, so we'll talk about what those are. I know that incentives are against you, but at least for me, a decision to focus on diamond open access journals or community journals and to incentivize credibility. So for example, I have a pledge on my website called Check Me, Replicate Me, where if you find a mistake in my research, I will pay you. I invite you, I welcome this. And students check my research, so I pay my students. More often than the option to donate, they all decided to donate, and then I match it. So we've donated a lot to GiveWell. So win-win for everybody, win for science, win for the students, they learn from this, win for GiveWell and the world. So this is my first claim. Registered reports are the future of science. So if we understood that we have a publication bias, if we understood that we have outcome bias, hindsight bias, and people are trying to get into this p-value lower than 0.05, so we have all these questionable research practices, the question is there a way to get away from that? And there is, because our traditional model is broken. So we all know this model because we have to adhere to this, but we develop an idea, we design the study, we collect the data, we write the report, and then we submit this to the journal. But by then, it's already too late because you've collected the data, you've written everything, and then what is the peer reviewer's job? It's to find the flaws and reject. It doesn't even have to be flaws that have to do with the methods or the statistics. Maybe they don't like the findings. Maybe the findings were not p-value lower than 0.05. So reject, reject, reject. What are rejection rates? 90 to 95%. And then we just get a lot of rejections in academia, especially when we submit to journals. This is a broken system, and it doesn't help us do better research. The only thing that we can do, scrape everything, start again, collect another. Or try another journal, going off from the high impact factor to the lower impact factor. Another model is the register report model. So the register report model is you write a pre-registration. If I can do this with my second to fourth year undergraduate students, anybody can write a pre-registration. A pre-registration is basically your manuscript. You have an introduction, you've got a method, and the results are based on simulated data, not the real data. We're talking earlier, Qualtrics has a way to simulate data. With one click, you can stimulate as many participants as you want. If you don't have this in Qualtrics and you use something else, there's lots of Shiny apps that will create the data for you. So the only way that I know whether a pre-registration is solid or not when my student does this is that I can see all the data analysis in R or Markdown based on similar data. Then we're all aligned on this. Once we have this, we submit the pre-registration plan to the journal. This is what's called a stage 1. And then the question is, do you have good hypotheses? Are they well-founded? Are the methods and the proposed analysis good? Is this well-powered enough? Do you have sufficient controls? And if it's not good enough, it's not rejected. There's no reason to reject because you can improve this. No data has been collected. Let's just all work together. So when I shifted from regular work to registry reports, our rejection rates dropped. So originally with replications, 80% rejection rate. Our rejection rate in the last 2 years doing registry reports it's 0. There's no reason to reject you because everything that you can, everything that peer reviewers suggest that you should do, we can just do. So you work together. Sometimes the feedback that we get from reviewers is so good that I want to give them credit. I want to give them co-authorship because they found mistakes. They helped me improve on this. And they also helped me gain some confidence in my students because it could be that I'm too burdened or busy to find something. Maybe I'm biased. So this is a revolutionary thing. But the thing that takes this into a whole different level is that once authors, reviewers, and the editor agree on the plan, you get an in-principle acceptance. It means that no matter what the outcome is, p-value lower, higher than 0.05, supported, not supported, successful or not successful application, is going to get published. So the only thing that happens in peer review in stage 2 is to check whether you follow the pre-registration. And if you did not follow and you have some deviations, whether you've documented deviations and you justify them. And the justifications seem solid. Right? So this changes everything about the way that we do science. So from all these problems that we have in the life cycle about no power and questionable research practices and a bunch of other things, we come into this model of no publication bias, no outcome bias, no Hudson bias, no reason for questionable research practices because it's going to get published. And then you've got solid findings. And we have increasingly more and more support, meta-scientific support that registered reports are working as intended. Because, for example, the positive results, p-value lower than 0.05, which when we look at the literature is above 90%, when we do a registered report, it drops to about 50%, even lower than that, depending on what your research is, how complicated it is. Yeah. So it seems like things are working as intended. Now, I want to make the claim that this is not just good for science, this is also good for you. So I give workshops on this. I'll give a workshop in a couple of weeks in education on HKU. First, you just do good science. There's no stress over the amazing and significant results. You get constructive, positive expert feedback when it really matters and can actually influence the work that you do. Higher acceptance rates. So I don't know if you're a neuro or something, but Cortex is a good journal. This is where Chris Chambers first did the registered report model. He says that they dropped from 90% rejection rates in regular articles to 10% in stage 1. And this is, even the 10% are about the things that were just technically not good enough. They didn't even understand what a registered report is. But 0% rejection rate over stage 2, which is unbelievable, right? Then if you have an in-principle acceptance, just add this to your CV. It's a guaranteed publication. So all of my students that do these things with me have a line in their CV saying that they have a guaranteed publication. Now, registered reports is already a revolutionary model, and it's endorsed by 350 journals, but it still has a bunch of problems. The biggest problem for me is some people were saying it takes a lot of time. And I was worried, how am I going to do this in one academic year? One of the things that came out is called Peer Community in Registered Report. Chris Chambers and a bunch of others who are in the open science community has formed this. I can talk about this for a very long time, and they have a lot of revolutionary things. For example, open, citable, identified if you want, peer review. So I, as an author, can say, I only want reviewers who are identified. It's important for me because I do replications. So if somebody, this is on my work, I really want to know who that person is. And if it's the original authors, then I want it to be public that they are the ones who did this. So I can request identify. But then it's also open and citable. So the reviewers who contribute to my research, it's a registered report. I cannot make them authors, but they can add this as lines to their CV saying, we reviewed that literature. Go and see what we wrote on that. And then one of the big innovations is that they guarantee peer review within 2 weeks. This is how I was able to do this with all of my thesis students. There's a magic to it. I can go into that magic, but just so you know that there's a way to do this, and it has to do with something called a snapshot. So 6 weeks before you want the scheduled review, you submit a one-page plan. They recruit reviewers based on this, and we all aim 6 weeks into the future, and then they guarantee to do this within 2 weeks. Finally, and this is the really revolution in science, and I think all of us are not aware of this, but this is done by the community, for the community. There are no for-profit publishers. Everything is open, citable. Everything is by the community. But we cannot survive without all these impact factors and without all these for-profit publishers. So some journals have committed to If the community endorses this, then we will publish this with no additional peer review, which is unbelievable. So first you do this, and then as an author, once it's endorsed by the community, you decide which journal you want to go for. And then, happened to me, they see that I was endorsed by the community, they reach out to me and say, would you consider publishing with us? And then I say, but you're asking for APCs. I don't have $10,000 to give you. They said, no, we'll waive the APCs because this seems important. So suddenly I have power. First time in my life as an author, I have power. Yeah. Which journals are here? It's a little bit too small, so I'll just tell you. Cortex is here. If I would be a neuroscience person, I would just go peer community register reports all the time and just get this endorsed by Cortex. Then you've got Collabra Psychology. So Simin Vazir, before she was in psychological science, she made Collabra endorse this. Then we've got all these other Meta Psychology, International Review of Social Psychology. This is just in my field. You can look at others. But there's also another category called PCRR interested. Every time we get an endorsement, stage 1 endorsement, they reach out to us if they're interested. So one of the things that you can do, let's say that you really care about nature human behavior. You have a proposal. You first write to Nature Human Behavior and say, I have this registered report, but I want to go down the PCIRR. Can you please tell me, if I get a stage 1 endorsement, will you consider doing this with Nature Human Behavior? So they are willing to have this kind of process. So then you have a lot more power. So this is revolutionary. This is only after 2 years. I can't even imagine after 10 years what's going to happen. And more journals are joining every month. So is this really working? And I can tell you, I've been doing this for 3 years. It's a very successful proof of concept, doing this with undergraduate students and top masters. Everybody's submitting to peer community and registry reports. Anybody who's doing a thesis with me goes down that path. I won't go into this, but this is how I do this with my thesis students in order to make sure that this is really on time with peer community and registry reports. And you can go and click on any of these links in order to see what that looks like. But generally, I would just say, I'll give you 2 examples. This is Chris Chambers, was our editor, our recommender in peer community and registry reports. And finally, Collabra Psychology automatically published this, and they waived our fees. No 1,000 US. And then you can see everything is open. What we submitted first, what the review was, how we responded to the review, all the simulated data. Then when we collected the data, all the data, everything is shared, everything is open. You don't have to guess anymore. This is the highest transparency and credibility that I've seen anywhere in science. And everything is accomplished by this peer community in registered reports. Timothy, one of my undergraduate students, did 2 of these things. It's unbelievable. He did this within his undergraduate. He did 2 of these registered reports with me. So he gave a talk at HQ Brown Bag. You're welcome to go and visit this on YouTube. He also wrote, we have a column on Psychology Today where he shared his journey. It's unbelievable. So now he is sought after, as he's done as an undergraduate, just leaving HQ. He's got 2 publications in places like Collabra. This project, Cognition and Emotion, unbelievable. So really, really amazing. How many of these have we done? I've done this with 30 different students. So you can go and you can click all these links. It's doable. It's possible. I've shown that this is possible. So now we don't have to go with these for-profit publishers. We can do everything together. Right? If you want to know more about peer community and register reports, I give a lot of workshops. You can come to HKU and join one of my workshops. Or if you prefer the comfort of your own homes, there are lots of videos with the founders, for example, Chris Chambers of peer community. If you want articles, so this has been published and this is going to get more and more prevalent. So the past, present, and future of register reports, Chris Chambers has a bit more on that. And finally, everything that I talked about today, the team that we have, the problems in science, the solutions that we have, peer community, all our examples, all our templates, all our guides, everything is on my website. So if you have any question, if you have something that you're doubting or something that you don't know how to implement, I've supported a lot of people in various places around the world. We have a big team. Even if I'm busy, I can connect you with somebody else who does this. We're very happy to support you in your open science journey. If there's something here that you want to do and you're not sure how to do, we can help. So you can either use some of the things that we've done, or I can give you some paths for you to follow. Just let me know how to best support you in your open science journey. And hopefully we'll get more open science scholars to remain in the system and survive in the system and do well in the system so that in 5-10 years time, we'll all do better. So thank you very much. And I'm happy to take questions.
I have a quick question about, because I have a friend, he's an AP in business school, and we talk so much about data sharing stuff. Like he's always keep saying that even though people choose to sharing their data sets, they have already cleaned that data. So they're not sharing the raw data. We have no idea how they clean or how they train the data. So in this open science frameworks, how do we deal with these kind of situations?
Yeah, that's a very good question. First, I will say specifically about the business school, because I grew up in a business school, so I know some of the problems. One of the common issues that they say, many of them do field studies, or many of them go and work with companies. And first of all, they say it's confidential. The companies do not allow me to share. Therefore, I cannot share any data. So we in the open science community love these kinds of challenges because it allows us to rethink and adapt some of the practices that we have. So for example, for this kind of thing, not just with the business goal, but also in health. Identifiable data is really a problem. If a hospital gives you some data that you need to protect their identity, what can you do? So we sit together. We have this conference every year at Society for Improvement of Psychological Science. And instead of just tapping ourselves on the shoulder and just saying, oh, we did such a good job, look at how wonderful I am, we sit together in a circle and we work on real problems. So one of the problems that we're early on, that we sat on and worked on, is somebody saying, okay, we need to share confidential data. How do we do this? And now we understand there's a way to do this. And it's called synthetic data sets. So basically it means that we create another data set with the same statistical properties as the original one, as the raw data with everything on it. And then we give a third party who is credible to see both of them. They are the only ones who get. And then they verify that these two are compatible, and then we share the synthetic one instead of the confidential one. So there are ways for us to make progress in even sharing things that have to do with confidential data. In addition to this, when it comes to how much to share, we aim to have things as reproducible as possible. So once we took away all the identifiable issues and everything is anonymized, we want to have as much as of what was collected originally to share that. And then we want reproducible code that would go through that and then do all the cleaning, then do all the recomputing, then do everything, and then to match that as close as possible to what's reported in the manuscript. So definitely, when I'm a peer reviewer and I get access to the data, I want to see not the cleaned up version. I want to see from the beginning to the end. I'm happy to see also the end result, but I want to see all the code that led to that, because I want to see all the decisions. I want to see all the exclusions. I want to see what you dropped. I want to see the analysis. Maybe something in the way that you cleaned your data could be wrong. So it's not just to check you, but sometimes to help you. And we've identified some errors in our data. So when you share as much as possible, it also allows the community to find the mistakes early on, not 30 years once you're a full professor, and then you've got things like Juliana having you go on Twitter and saying that they're ashamed, but you find this when this actually happens. So you use the power of community, you do science the way it's intended to do, to really help you from the raw data, unidentified raw data, all the way to what the results in the papers. Hopefully, in someday, and we're getting very close to this, you can have with R Markdown or Quarto to be able to just write your manuscript inside the IDE. So finally, when you look at the results, you know exactly which number came from and where. So we have increasingly more and more manuscripts that do that. But we need to have also standards for how to share data. We need to have solutions for how to share data that is confidential in order to support everybody. So if there's an additional question that comes from either business or some other field where it's not clear how to do things, then they can reach out to open science community, to me or some of the others. So we'll come up with some solutions. But we definitely need to address to help people how to do this well, so that they can make sure that they know how to do this well, how to share this with the community. I also want to say that it's also important for us when you revisit things that you did 5 years ago. Let's say somebody comes up, forget something. Let's say that you want to check your research that you've done 5 years ago, and you want to know how you got to this cleaned data. You have some questions, or you want to look at something else. You want to know the process that you went through. So it's very good for you to share as much as possible, as early as possible, of course, without violating confidentiality. But all these things are things that we should have discussed before. When I came into my PhD, I thought everything, science works. And then I realized it doesn't. So maybe I can help in making this the science that I was hoping for it to be. So we're working on solutions. So bring up your challenges, ask these questions, and then help us to help you do this better. And so it's appreciated. Does that answer your question?
Yeah. So I think so. When you just answering that, I come up with another question. Like just when I talk with my friends, like, well, I think one of the concern that they're not willing to share the data is like they try so hard to collect those data and they have ideas how to do analysis and stuff. And they still have some concerns that they haven't done with those analysis. It feels like, oh, we might have different ways to keep on investigation. So I think that that's one of the reasons you don't want to share, because they want to share the data sets. And so, oh, I have found the data sets and have cool ideas to do analysis on that. I can use that data and get my data. I guess and figure out. So that is one of the concerns.
Wow.
So
it's such nostalgia. It brings me back to the days of the business school. Yeah, I remember this, and I understand this. But of course, now the way that I look at this is completely different. In that, once you start sharing, one of the nice things that you realize is that actually it could be that once other people know about your plans or what it is that you're doing, rather than scooping you or taking your research and doing something that before you do it, people reach out to you and want to work with you, and then perhaps they've already done this. So I've had so many collaborations come out from me sharing stuff and people reaching out to me and saying, this is cool. You've got the study, we've got the study. Maybe we can do this together. Maybe we can work on the future things together. So actually opening and sharing has brought me zero negative consequences and a lot of positive things. I will not reject if somebody comes to me and says, no, somebody stole my research. I'll say, could be. But let me just say that when you share, you don't just share this, let's say with a pre-registration. You don't want, you don't just put a file out there, but this is a time-stamped DOI plan that you put out there. So actually, you make sure that everybody knows when at what time your thing came out. And then if somebody comes out with another thing, you can say, but I was there first. And then you have a way to demonstrate this. So when everything is open, when everything is timestamped, when everything is a DOI, actually we can assign credit more carefully and more transparently. And people get the credit that they deserve and allows for more collaboration. That's my view on this. And a really shift that I had from the business school to the way that I do open science and psychology now. And I appreciate it. Thank you.
It's a very nice talk. I enjoyed it very much. So it seems that we're talking a lot about changes in the field, and I'm all for making science more, rigorous, more open and all that. I'm just wondering how you see it as a challenge in moving forward, because it seems a lot of the problems are intertwined. They talk about the incentives of the universities and people model in the journals and the metrics for evaluating researchers and all that. So it seems that they're all related. So I'm sure there are a lot of challenges that you didn't mention. So my first question is, what challenges do you see with this kind of changes? Maybe like word I would say maybe it's some kind of revolution that we're doing here. So what are the main challenges? And the second question is, what do you see this where do you see this whole thing moving forward in, let's say, 5 or 10 years? How is the field going to change? As you mentioned earlier, that things are no longer the same 3 years ago, right, compared to now. So how do you see this whole thing going to be like in 5 or 10 years?
Yes, thank you. It's a good question. Like I think about this a lot. So I think about the big problems, what my role in this, what we can do. When I started doing these things, coming to Hong Kong, I really thought, we're going to build this wonderful open science community in Hong Kong. I'm going to find people with the same kind of mindset. We're going to do some cool stuff together. But I can say after 7 years that generally in Hong Kong and in HKU, I've failed. And I feel like the incentives and the power structures and the hierarchy and the status quo is so strong that it doesn't matter what kind of enthusiasm you come in, what kind of change you want to promote. It doesn't matter that it works better in the Netherlands and the Scandinavians and the UK is doing. It doesn't matter. Maybe it will affect a little bit the way that we do ref, more diamond open access, this kind. But change is very, very slow. Status quo is very strong. Sometimes it requires a whole generation getting outside of an academia for a new generation to emerge and make a real change. But I think it would be a shame if we would have to wait for that to happen. So what I can generally say is that there are rays of hope in various places, in various fields. And over time, now that we have had a decade of these things, you can see some things are changing, especially in social psychology. I understand some of the other types of psychology in the business schools, things are a little bit slower. But there are changes happening. And some external shocks. You mentioned Francesca Gino, in the Netherlands. The reason why they're so much ahead of the others is because of the Dietrich Stapel, the social sciences dean that had a fraud case. So sometimes external shocks are the ones that get us moving. And because of these external shocks, things like UNESCO endorsing this, or NASA endorsing this, or the Biden-Harris administration endorsing this, or the European Union, because of external shocks, sometimes there is a moment where a change can happen. There's also other external shocks, like the rise of the right wing, and some of the cutting in social sciences and humanities are pushing back on that. So there are some good things, there are some not so great things. So it's kind of like an up and down. But overall, as a trend, I would say it's on the right path. And I would also say, if you care about this, and you did not find the way to implement this in wherever your environment is, in most of the places in the world, especially the weird Western world, there are now universities that support this move. So you can find a more supportive environment. You can surround yourself and work together with people who care about these things. So I don't have an open science community in Hong Kong, but I have a very active open science community in the European Union, in various places like the Brazilians or an unexpected ally that emerged. So increasingly you find more and more people who did this kind of work. And then occasionally, like for example, with peer community and registry report, in 2017, this was a dream, this was a fantasy. Suddenly in 2021, Chris Chambers comes out with this Register Report 2.0 that I see that this is working and more journals are coming. This is real hope. Center for Open Science with the Open Science Framework, unbelievable stuff. Top factors competing with it. Amazing changes that are happening, but they are pending. I'm really hopeful, and this is what I aim to do with this kind of team, that after 390 course students, and 50 thesis students and others, they will go out, they will spread the word, they will be in foundation, they will find places where their passion will come to life. And then hopefully in 5-10 years, everything will look different. Social psychology is definitely headed this way. I would say business schools management are 5-10 years behind. But things are changing. I mentioned the psychological science. We never imagined Simin Vazir going to become an editor in that journal. We never expected JPSB having these editors, even actually human behavior doing all. So things are changing even in the top journals. It's a little bit slow and it's taking some time and it's not for everybody. And but I am more hopeful for the discipline to be different in a decade than I have ever been. Lots of challenges. I don't know how I'm going to be affected and what's going to happen with me in a year. But for the society, for the community, for science, I really feel like things are going to do better. Now we need to fill in the gaps so that we understand the situation where we know what credible science is. And in the age of disinformation, how we work together with practitioners, with our students, with people in the field in order to help them identify what is credible evidence. This is a big challenge that we have right now. And we're working on some solutions, but it will take some time.